All right, guys, here we go. We're gonna do the last of these math questions. So number 21 is a bend allowance question. So I'm sure a lot of you have forgotten how to do this. I know this drawing I have here is probably a little confusing right off the bat, but if you remember, there's two distinct parts to doing a bend allowance calculation. Step one is going to be calculate the setback and subtract the setback off of each leg. Calculate the bend allowance and add to the new leg lengths. So I've made a drawing here of the piece that's in that question. So it's got one leg that's 12 inches long, one leg that finishes off at 11.5 inches long. It's got 150 degrees of bend in it, and it's got a neutral line at 30%. The material is 1/8 thick, and then it also has a inside bend radius of 1/8 of an inch. So that 150 degrees is not important. What we need to know is that it bends up 30 degrees here, right? From flat up 30 degrees. And whatever angle this is what this angle here will be. So this angle, this is how we're gonna isolate the straight sections from the part that's actually bending. And that's where we find our setback. So if we have that 30-degree triangle there, cut it right in half, then we end up with two 15-degree triangles. Hopefully you guys remember this. So I've drawn the 15-degree triangle here. So 15 degrees, the setback is going to be the opposite. And then we have a measurement on the adjacent, and that's going to be 1/8 plus 1/8 material thickness, right? So 1/8 and 1/8 equals 1/4. So if we go tan 15 degrees times 1/4 inch, it gives us this big long decimal here, 0.066987298. So this is still part of step number one. I'm going to take that number off of both of these legs. So 12 minus this number gives us this leg number one here of 11.9330127. 11.5 minus that setback gives us 11.43300127. So that's step number one done. Step number two is going to be calculating the bend allowance. So the bend allowance, now if you remember, we're going to be using the full angle here, and we're just trying to find this little piece here. I drew a green circle to imagine that it's just a portion of a circle. So that's that old formula we've done a million times. Radius times 2 times pi times angle over 360. So the angle that we have here is 30 degrees over 360. The radius is going to be the 1/8 inch bend radius plus the 30% of 1/8, right? So radius 1/8 plus 30% of 1/8 material. So 0.125 plus 0.0375 gives us 0.1625. So that's going to be the radius. So we can put that in place of the radius in this formula. 0.1625 times 2 times pi times the angle over 360, or 30 degrees divided by 360, which gives us this number. So that times that times that times this number gives us a bend allowance of that. And then we just add them all together. So 11.9330127 plus 11.43300127 and plus the bend allowance of 0.085044, or 848. And that's a total of 23 and 29/64. I know that's right because if you remember, if I add up my legs originally, 12 plus 11.5 is 23.5, and this is slightly less than 23.5. So it can't be 23.5 or bigger. It has to be less than those legs because the metal is actually stretching. Hopefully you guys remember that, and hopefully that's a good explanation and helps you remember everything in that deals with bend allowance, because there definitely will be questions on the IP that have to deal with bend allowance, and same with on the math test. All right, number 22, 23, and 24 are all relatively simple. Number 22 is just looking for the stretch out of an 18-inch diameter duct with a 1/2 inch lap seam. So that's just 18 times pi plus a 1/2 inch. gives you 57 and 1/16. It's actually a little less than a 16th. I just, you know, it was 0.07 or something like that. So, or 0.7. I just rounded up to 1/16. Number 23, it has a surface area of a cross-sectional portion of a duct. So the area was 1728 square inches, and they were the duct is 48 inches wide, and they wanted to know what the width of it is. So area is going to be length times height. So this times this equals this. This divided by this is going to equal this. So 1728 divided by 48 is going to give us a height here of 36 inches. Last one here. We've already done a question on this test that's very similar. The numbers are actually almost the same as well. But if we just change the millimeters to meters, it's going to be 1.26 meters, and this one here is 0.45 meters. I have the formula here. Volume is pi r squared times height. So volume is pi times 0.225 squared times 1.6. So that was the 0.45 divided by 2 to give us the radius squared times pi times that. That gives us 0.200394341 cubic meters. Times that by 1,000 to give us how many liters there are. So gives us 200 liters if we round it off to the nearest whole liter. Moving on. Number 25 was, again, pretty easy. This one here, they're looking for the surface area of the duct. So it's not going to have any ends to it. Again, this had millimeters in it, 1,600 millimeters, 4,800 millimeters, and then a length of 3 meters. So I just changed these to meters as well right off the bat. So surface area is going to be the perimeter times the length, right? So we have to add all 4 sides of this and then multiply it by the length to give us actually a surface area, like a cubic meter surface area. So I've got it 1.6 times 2, one there and one there, 4.8 times 2, one here and one here, and then times those by 3. So I've worked it all the way through, and we end up with 38.4 meters, but they're looking for the closest whole meter, so 38 meters squared would be the surface area of that duct. And then finally, this crazy offset question. I really don't like this question at all because it leaves too much, it's a little confusing. Because the way it was drawn, it just has the 10 by 10 duct here, 10 by 10 duct here, 45 degrees, a 10-inch throat radius, a 22-inch offset. But drawing the offset down at the bottom, if it's 45 degrees, that means if it's 22 this way, it's 22 this way. So the only way to make this work is actually to have it from the center of the elbow here to the center of the elbow here, 22 and 22, to be at a 45. So one of the first things you need to do here, I've actually made a triangle in green, which is that one right in the middle there, and I brought it over here. So I'm going to do a squared plus b squared equals c squared to get us this length of the hypotenuse. So right here, 22 squared by 22 squared is 31.11269837. Then we need to figure out a seam height, because if we take this rectangular elbow or square elbow here, and if we go right into the center, it's going to go up a certain distance and the same amount this way. So if we just treat it like a seam height, then we have a measurement from here to here that we can subtract off of that hypotenuse. So I've made the little triangle here to figure out a seam height. So if it's 45 degree elbow, half of that's going to be 22.5 degrees. From the 10-inch throat radius to the middle of it, it's going to be 15 inches, and that'll give us the seam height here. So tan 22.5 times 15 gives us 6.1 or 213203436. But we're gonna have to subtract it off once here and once here. So I just multiplied that by 2 to give us both or 2 of those dimensions. And then I just subtract 12 off of the 31, which leaves us with a duct length from here to here of 18 and 11/16. from there to there. All right. Again, don't worry too much about this question. Normally when they have a question like this, they're actually going to give you a height here, which makes it a little easier to figure out. You do the same process by getting a seam height, and then you would actually subtract the seam height off of this, like twice. You take the seam height off of here to give us a height of that triangle, and then the offset would stay the same. And this typically wouldn't be 45. If it is 45, you know that the length this way has to be the same length that way. So the only way to make this one work is the way I showed you. Kind of a crap question. I doubt you would ever see anything like that on a test. It would give you a length here and a length of offset, and then you would subtract seam height there, get to a smaller triangle in here, do a squared plus b squared equals c squared, and then subtract the seam height again off of that. So anyway, if you have any questions about this, just give me a call or email me and I'll try to explain it better. Hopefully that was good enough. All right, talk to you guys later.